This old guy DIY video has to do with the joys of boating. A friend asked me to help her get her boat into the water, so we pulled it out of the garage today. As I came to the lower unit just to check the lube, I saw this, and it looks like that little bearing carrier has separated from the housing. So as I look up here, that certainly doesn't look good. So now it's time for me to pull the prop off and see exactly what we have. And the reason I was back here, other than checking a lube in the lower unit, is there's a leak in this cylinder, and I was going to disassemble that and replace the seals. So we'll see how this works out. Well, I removed the prop, and to remove the prop on this motor, you just take the little key out of that hole, and you can see this thing is threaded, and it's just a retainer for this roll pin that goes through the prop. So you just push that roll pin out, and the prop can be just pulled off. Now if we look at this thing, we can see that the housing is broken. So I'm going to remove it, and we'll head for the internet and see if I can find a replacement. After removing the carrier, you can see the fluid here looks like the oil is contaminated with water. Now I'm wondering if in the course of the winter, when the water froze, as the water expanded, if it actually pushed the carrier out, because that was less resistance than cracking the housing on the lower unit. So right now I'm suspecting that the root cause of this problem was water in the lower unit that expanded and then broke that casting, rather than some type of impact, since the prop shows no evidence of impact or anything that would have caused that fracture. I went online to see what options I had for a replacement part. There's one OEM piece listed on eBay for 179 bucks, a couple of used ones for $110. I talked to the lady that owns this boat. I told her the whole motor, it's a 1994 forced by a Mercury 40 horse. The whole motor is probably worth 500 bucks, and I wouldn't put $150 or $200 into this thing, which looks like basically a poor engineering job. I did pull the plug here and drained out the fluid, which is mostly water. So that pretty much confirms my theory that expanding water is what caused this break. But my plan now is I put the prop back on just to see what it looks like in terms of clearance. If I set this thing up to the edge, if I change from that sunken cap head screw to a normal hex bolt, I believe I can hold this thing in there safely and not have an issue. So my plan right now is to take these clean brakes, clean them up with a little bit of gasoline, and then I'm going to JB weld this thing back together, and I'm going to fill that hole with JB weld, and then I'll drill a hole down through it afterwards and put a regular hex head screw in there, and we'll see how it holds. So I'll take these screws to town tomorrow and find the right size, and I'll get back with you. I have the pieces of casting ready to accept the JB weld, and I mounted that little carrier back so it's clocked a little bit off position, and then I'll just insert the casting back here and then rotate it over to line it up with the hole, so that way I have clearance to put both of those little casting chunks in before the glue sets up. It's day 2. I let my JB weld set up overnight. When I came back, this one needed to be drilled out a little bit because the JB was in the hole, and when I drilled it, this piece fell off, so my JB weld didn't do a very good job here. I'm going to try some JB clear next, but in the meantime I wanted to dry fit these 5/16 bolts. I went and bought some 5/16 by 18 by 1 inch bolts to replace the little cap head screw that was on there, and 1 inch is too long. So I wanted to dry fit this thing and see if there was clearance for the washer to sit there. So the washer sits fine. You can see I haven't buried the bolt, but I hit bottom in the hole. So I'm going to go now and put a nut on this bolt, so that'll act to chase the threads when I'm done cutting it. I'm going to grind off about 4 threads with my Milwaukee grinder, so I should take it down to about 3/4 of an inch, and I'll come back and see if it works. And when I grind the end off of a bolt, like I just did on this stainless steel bolt, I'll put a nut on there, so then I can take the nut and chase what I just cut and make sure that the thread is fine, particularly when I'm screwing into aluminum. I don't want to try to drive something into that aluminum and let the aluminum tear out because the end of the bolt isn't proper. I just cut the second one off, so if I chase it with the nut, comes off nicely, so I should be able to put that into the aluminum housing without an issue. And here is my $4 solution to my $100 problem. So rather than replace this whole propeller cage casting, I did my JB Weld special. I went and bought some 5/16 by 18 stainless steel bolts with stainless steel washers. If I had bought 3/4 inch, it would have worked fine. I bought 1 inch, so I had to cut them down to 3/4. But they both drew down. The seam here looks good. They did not bottom out. So now I'm going to disassemble this one and redo my glue job here with some JB Clear, and then reassemble it. And in just a moment I'm going to dry fit the prop to make sure I don't have an interference problem. Now it appears that the prop does in fact interfere with the top of that hex head potentially. So I'll go and grind some off the top of the head. I don't need the whole surface anyway, but I'll grind that off to make adequate clearance. So I took the angle grinder and took about the thickness of a cutting wheel off of that head. Here's this head from the company. That's one I modified, and I'll do the same thing to this one. And here's the second one. It has that little piece I cut off still on there. I'll knock that off right after this photo. As long as I'm here with the grinder, I decided to cut some off the washer also. So when I put it on that housing, there shouldn't be as much drag just as the water flows over the prop housing. And here's what the before and after look like for this little operation. This is what it looks like after my modification to the bolt and the washer. Now when I put the prop on there, there's no concern of interference. So after looking at my failed JB Weld joint down here, I speculated that maybe since I didn't have any compression force on it yesterday when I put it together, the thing failed. So using the same products as yesterday, regular JB Weld, I made that joint whole again, and then I just tightened this bolt and washer on only to hold the joint. Tomorrow I'll come back after that stuff is set up and I'll orient this washer so it's not hanging off to one side. This one is compressing the joint also. It's not aligned the way it will be tomorrow. I'm back for the third and final morning of this project. So my JB Weld is done on top and bottom. My stainless steel 5/16 bolts with their heads cut off to allow for clearance are in place. And now I'm just going to spray paint the stainless black, reinstall the propeller, and call it good for another year. Bolt heads and washers are black. Now I'll put the propeller on and be done. And this is the final shot. The prop is installed. You can see we have clearance here. So we're going to call that the $4 solution to the $120 problem. I hope this idea helps you. If you haven't subscribed, please do, and I hope you have a great day.